x-axis. So I've drawn a coordinate plane here. I got us ready for the meeting. I've got the x-axis is always the horizontal and the y is always the vertical. I labeled my numbers. I duck out of view for a minute. I always start with the origin. The origin is where both the x and y cross together. It's 0 for both. And I labeled the x-axis. Every unit on my graph right now is worth 1 because that's the problem in the book. It was worth 1. Same thing on the y-axis. The x and y aren't always the same, but this problem they are. So 1, and I just labeled a few out in both directions, especially in the negative. I take a few minutes and I start to label them off because when I get going, I'm likely to mix up that 4 and 1. I know me. I know the mistakes I make. And then down from the origin, down 1 step, down 2, 3, 4, negative, that way. So that's the first thing I do before I even get started with the problem that I know I have to graph on the coordinate plane. I draw my plane and I mark off a few points so I can get going. I know the problem says to reflect this point on the x-axis. So the first thing I want to do is I want to graph that point. What is this? A few colors here. What is this number? What coordinate is this? You know it? Would you write it on a piece of paper or flash it up or do something with your hands or let us know what it is? What coordinate is this? This is called a coordinate pair because there's 2.
Ordered pair.
And it's a ordered pair. It's a coordinate pair. Either way. So this first is the x coordinate and the second one is the y. It's always that way. X comes first in the alphabet. So, and y comes second, so that's the way it is. And they call it ordered. It is in that order, and it's coordinate. All right, so the first thing I want to do is I want to go ahead and plot that point on my graph. I see the x coordinate is -2. I'm going to start at the origin, and I'm going to go over to -2 on the x-axis. And then it says y to go down to -1, so I'm going to go down right here. And when we graph on the coordinate plane, we do that, and then we put the letter that goes with the points. We don't have so many things out there. And so it's -2, -1. When I read the point off, I touch the x first, and then I touch the y second, and then I read the point off. So this problem says to reflect that on the x-axis. Reflecting really just means if I took a mirror and put a mirror on the axis they told me, in this case it's x, where would it look like the point would be? Where is its reflection? Where would it be? So I'm going to ask that in a minute, but first I'm going to order. I'm going to write down the quadrants. This is known as quadrant run, and they write it with a Roman numeral. I don't know why. I just know it's always written with the Roman numeral. And that's quadrant 2, this is quadrant 3, and this is quadrant 4. So if it says to take that point and reflect it on the x-axis, I'm really thinking of putting that mirror on the x-axis. What quadrant does it look like A is, the reflection of A is in? What quadrant would it be in? See, I can only see Jason. I see he's holding up 2 fingers. It looks like A is reflected right there. So let's see where it was reflected. It looked to be right about here. Now let's take a look at that. It says to reflect on the x-axis, and let me talk about reflection. When you reflect on the x-axis, the x-coordinate stays the same. I feel like I'm teaching junior high again, where I did the same thing a couple times in a row, and then I forget what I said and what I was going to say. All right, so the x-axis is, the x-coordinate stays the same. See, and I already had the wrong thing. The x-axis stays the same, and the y-axis change, and the y-coordinate changes. Let's take a look at that. Let's look at point N. If I was going to read point N off my graph, and that's just what it looked like. The x would be -2, and the y is +1. That's just where the mirror looked like it was going to put it. here's what I'm seeing. The x-coordinate stayed the same because it was reflected on the x-axis. The y-coordinate changed, but the y-coordinate changed in a special way. How did that y-coordinate change? If you know it, you can unmute and let us know.
I'm not sure I understand the question, Mrs. Brown.
The y-coordinate changed. The y-coordinate changed, but I'm noticing that it has the same digits, but they are opposite signs. So the y changed to its opposite.
It's integer.
The opposite integer.
The opposite, it's opposite integer. Here, y is 1. The opposite of 1 is -1. Here, y is -1. The opposite of -1 is 1. So when you reflect, the axis you're reflecting on, that coordinate stays the same. The other one becomes its opposite. And really the best way to do that is really just holding that mirror on and seeing where you think that that reflection would be. I'm trying to think what we did before. Okay. All right. So the next thing, it said to label that as N and put it on the graph. So we went ahead and did that. So that was that point. I could reflect A on the y-axis as well. So if I reflected A on the y-axis, what quadrant would it look like A would jump to? I'm trying to get the mirror right in the right place. So if I put the mirror this time on the y-axis, what quadrant would it be looking for? Jason's saying it is quadrant 4. He's one of the few people I can see. I see Mrs. Nelson's telling me it's quadrant 4 as well. So let's see if I do reflect A. Let's see if my rule of thumb works on the y-axis. So point A is -2, -1. I'm reflecting it on the y-axis. My new point will have the same y. And my x-coordinate should change. The opposite of -2 is +2. So it should change to be this point. I'm going to make a new point. I'm going to call it point S. So it's 2, -1. I'm going to graph that and see if that looks right. Over 2, down 1. I'm going to put point S here. So putting point S here, it does look, it's the same space. It has to be the same space from the axis I'm reflecting on. That's why it's the opposite, because remember the opposites are the same distance from 0, and the axis is where a coordinate is 0. Okay. This chapter is about making polygons on the coordinate plane. It's about graphing things and finding the distance of things. What if I wanted to find this distance from A to S? What if I needed to know that distance? That's one of the skills from this chapter, is to finding the distance from A to S.
Oh, I like how you made that bracket.
So when I want to do the distance, the first thing I do is I want to write the coordinates of A. So I'm just checking. It is, I touch the X first, that's -2, and then I touch the Y next, which is -1. And then I want to look at the point S. Point S is, I touch X first, that's +2, and I touch Y second, that's -1. So I want to know what's the distance between those two. From looking at those 2 points, I can see that these 2 coordinates are exactly the same. So that didn't change. I really don't want to look at that. I want to look at the space here. And I see that for point A, it's -2, and for point S, it's 2. So if I take the absolute value of those two coordinates, I will get the distance. So the absolute value of 2 is 2. The absolute value of negative 2 is 2. The absolute value of positive 2 is 2. And the distance is 4. I always want to look for another way to check something. One way was doing it this way. Another thing, I really could just, these are the 2 points, I could just count 1 unit, 2 units, 3 units. Yes, they are 4 units apart. But now I've checked it 2 different ways and I've got the same answer, so I'm feeling really good about my answer right now. Anybody have any questions about reflecting on an axis?
I have a question about adding integers.
Okay.
So you added the absolute value of 2 to the absolute value, and then you got 4. If I were to add the integers -2 and +2, would the answer still be 4?
Would the answer still be 4? If I was at,
Who can answer that question?
if we were at 2, we were going to add -2. Would the answer be 4? I see a thumbs down. I see some people thinking and pondering. I can't see everybody.
Not sure. 'Cause This
Who's
is where
not
we're
sure?
headed. This is where we're headed. We need to know this. And really, if you can show yourself, you should show yourself during math class.
Yeah, it would be helpful. So we can see when you're giving a thumbs up, we can see when you're pondering. A lot of that is for us too, is seeing how you're, what you're doing, what you're thinking. That's a lot of that going on.
The answer is no, it would not be, right?
It would not be.
It would not be.
Okay. I want to draw another point. Just put another point way up here. Now I want to call it point P just because it's point P. So if I want to look at point P, let's find out what the coordinates of point P are. First, I'm going to touch X and I get what number? 2. And then I'm going to go over and I'm going to touch from that point to the y-axis and I get 5. I definitely recommend when you're doing these that you are using a ruler to keep it straight. Okay, not really accurate up here. All right, so from 2 and 5, I want to know what the distance is. Let's do a vertical one. I'm going to do the distance between point P and point S. So point P has the coordinates of 2 and 5. Point S has the coordinates of 2 and -1. Which coordinate is the same? Which coordinate is the same? In your math future, you might have some points that one coordinate won't be the same, but that's not going to be this year. That's coming later. That's a later deal. But right now, you always have one coordinate that's the same, and then you don't want to look at that. The coordinate that's different then, in this case, is the y coordinate, and that makes sense, right? One is higher than the other. One is vertically below the other or vertically underneath the other. So again, if I take the absolute value of the coordinates that are not the same, I should find the distance between those 2 points. So 5 and -1, the absolute value of 5 is 5. The absolute value of -1 is 1, and that's 6. And if I want to check it, I should be able to do 1, 2, 3, 4, 5, 6. 6 spaces or 6 units. If you don't know what the units are, we just say units. 6 units. Now this chapter, to use all my colors today, this chapter is about making shapes on the coordinate plane, making polygons on the coordinate plane. So if I connect those 4 points, I get polygon. The way we name a polygon is we just label the 4 points. So I have polygon ANPS.
They have to go in order.
They have to go in some sort of order, where you can start wherever you want to, but they have to go in some sort of order. ANPS, and I have a polygon ANPS, and from that polygon, I could find the area.
Those are also called vertices. Each one is a vertex. But if there is more than one, they are vertices.
Okay. So each point is a vertex. I could find the area. What polygon is this? What type of polygon is this? What does it look like?
Anyone, everyone?
Somebody? Somebody tell me. Jason, what is it?
It's a trapezoid.
It's a trapezoid. Usually we see trapezoids this way where the parallel lines are there. So it's a trapezoid turned on its end. So if I was going to get the area, if I had to find that area, I would have to find the area for a trapezoid. 1/2 height, base 1 plus base 2. I always have to look that one up. I would have to find that area, and then I would have to put in what I know. What were the bases? This would be a base. One base is 6. I would have to figure out what this base is. Oh, that's 2. And then the height is this height here. We already figured that out. That was 4. I would have to plug that in and solve that problem.
I would make it into 2 shapes. It'd be easier for me.
That's another thing we could do. You could draw a line right there, and you could deal with a triangle and a rectangle and add them together too, definitely. And then this distance still would be 4. The height now would be 1, 2, 3, 4. So you would have to know the formula then for a triangle, 1/2 base times height, and the area for a rectangle, base times height. I'm going fast with that because that was the last chapter. Perimeter is what you're being asked for. How do I find a perimeter? A perimeter. That's what I always think of in my head. How do I find the perimeter? What would I need to do?
I always think of a periodontist who works on my gums.
That's not a good memory, Mrs. Dawson. So if I'm going to find the perimeter, I need to know the distance going around a shape, right? I want to know the distance going around. So the perimeter, I would add up all of the sides. I would add up this side going from line segment NP, sorry. And I would add up, so I'm not sure I know what that is. I'd have to figure that out. I'd have to add up this and this distance, and I'd have to add up all the distances. What I like about perimeter is it doesn't matter what shape you're talking about, it's always just adding up all of the sides. I don't care how many sides you have, how complex the shape is, you just add up all the sides, however many there are.
We'd have to use the Pythagorean theory on that, right? We'd have to a squared plus b squared equals c squared to figure that out.
Exactly, and then they have to take a square root. So
That's definitely junior high.
that's coming in your future too. But right now you would have a rectangle, or you would have something that they would give you some information. But an area though, area's a little tricky because depending on the shape, I have to have different formulas for that. So that was a lot of information, guys. What questions do you have? How confident are you about the quiz on Monday? If questions like this were coming up on the quiz, how confident would you be? What do you need to do today and tomorrow to be more confident? Okay, go ahead. Oh, Jason, go ahead, ask the question about the slideshow.
What do we put in the spot where it says, how did I draw as a mathematician?
Well, the slide before it tells you some ways you grow as a mathematician. So use that to spark your ideas. What is it? What are those things that you do for the slide before it?
Do you have to use all of those, or do you only just put one?
Use the ones that apply to you. If it's 1, if it's 2, however many apply for you for today.
I'm going to go ahead and open up the breakout rooms for a couple of minutes.
Okay, thanks, Mrs. Nelson.
Welcome.
Ugh.